because I never did. Oh, my computer. Thank you so much.
You didn't have to do that.
Well, Richner and Steven can always borrow my things.
They should know that. Thank you, but you didn't have to.
Oh, it's all good. And honestly, it's the district's, right? It's not my property. All right, ladies and gents, let's do some math. My plan, I think Jose's going to teach the class. My plan, I don't know why I'm having to compete with so many people. My plan would be that we get our work done, and then you can work on homework and stuff, because I have like a folder full of papers to pass back to you guys. I know, it's up there, but some people don't read it. Yeah, I will not collect that until Tuesday, but that's only like 5 problems, so we'll probably have another new homework on Monday, so like try to get that done over the weekend. But I won't collect it on Monday, so in case you don't get it done. Hey, Aiden, will you put that stool at the back of the desk group, just so you can like face me and write? I'm fine with you being on the stool, but you actually, no, who stole my stool?
I did. I didn't know which one was the one.
Yeah, so I need something, because otherwise I won't wait.
And I was going to have to.
Sorry, I'll try to buy some more stools if people really like not sitting on the desks. I'll try to find some more. I found those off Buy Sell Trade. So I'll ask Mrs. Goldring too. She's like a Buy Sell Trade pro. Do you guys know what that is?
I'm not surprised. She's like, oh, she's.
Like it's only $15, right? It's like.
Only.
All right. So when we talk about all this math, there are always multiple ways to do it. So if you haven't put a header on your paper, please go ahead and do so. 226. And you can make it easier. You can put mult, mixed, hashtags. Right? We're multiplying mixed numbers. If we can remember what the abbreviation for multiplication, or if we can remember that it is MULT, if we can remember that the hashtag symbol really means numbers. All right, so as I've told you, my goal for the year, do I have the homework down? So I'm going to start to throw slides up there. It's over there. Too. Can you read that? Yeah, cool. Anyone else still need the homework? You good? Okay. My goal, as I said, is to try to make your life easier. Go. So when I present multiple ways to do things, you got to figure out what's easiest for your brain. And the only way to make that happen is through practice. Right? You can't figure out what works best for you unless you try it out and practice. So yesterday, we were looking a lot at the method where we did the rectangle and we broke it up maybe in half, and then we broke it again this way. Right? But that works well. But what if I gave you like 8/15 times 2/32? Like, that's going to be a lot of breaking up that we have to do. And actually, looking at some of your guys' homeworks, when we did the pizza problem with Mario and his dog, you literally drew the lines to break the pizza up into 24 slices, which is fine. Like, that's great, but it's kind of tedious, right? Like, it gets kind of tiring to break things up into that many pieces. So Audrey comes in and says, okay, so you guys are doing this rectangle thing, right? But that seems like a lot of work. She notices that if she just multiplies the numerator by the numerator, you can get the new numerator, and the denominator by the denominator, and get the new denominator, which is what we talked about yesterday with the arrows that we draw across. So to warm up for today, we're going to go straight to 96. So I'm going to label on your paper we're doing 96. I want you and your team to work through these fractions. Now, before we dive into these, I am going to review one more skill that will make your life immensely easier. Immensely means like a lot. A lot. Right? Here's, there's a few cases. All right, I'm going to remind you of one. Actually, so take a moment, write down A through F. Don't start solving them. We're going to do F together real quick. So write down A through F on your paper. Get the originals written down, because we always start by writing down the original work. Then we're going to do F together. I'm going to help you guys with that. Because today, because you already know this multiplication strategy, we talked about it yesterday. Today I'm going to kind of do some reinforcing of cross-reducing.
What if cross-multiplying is easy?
Not cross-multiplying. You cannot cross multiply unless you have a fraction equal to a fraction. So I got to get this through your head. We do not cross multiply yet. We're not there, and there's a very strategic reason why CPM did this, is we're multiplying straight through these situations before we're ever going to deal with that cross multiplication skill. That only happens if you have an equal in the original part of the problem. So we have 8/3 times 9/14. So please go ahead and write out F. If you're not there yet, get there, please. And somewhere make a little note that we are about to cross reduce, not multiply. Sorry, my C got a little rogue there. It just looks weird. Cross reduce.
Yes, ma'am.
I'm looking for Madison Kern. Did you hear me call you down? Okay.
It might have been during the class change. I didn't hear an announcement either.
Okay. All right. Thank you.
Do you need her?
Nope. She was reported absent.
Oh, okay. Yeah. Sorry, with form and everything, it might have just. You can always radio me and let me check for people.
I didn't know where she was.
Thank you, Deb.
Thank
Appreciate
you.
it.
Sorry to interrupt.
Were you late to form, Madison? Yeah, that's why we always say, like, get your butt where you need to be, like, get with, like, because if you're not where you're supposed to be, you might be kind of absent accidentally. Cross reducing is a great skill where all we're looking for is a common factor that two numbers can divide by, but they have to be crossed, not across, but like diagonal. So when I look at 9 and 3 here, an alarm goes off in my head. Both of those numbers could be divided by 3. So I divide by 3, and that becomes 1. I divide by 3, and this becomes close 3. So please show that work on your paper. You can write a little divide by 3 if you want to make a note to yourself if you think you're going to forget. Because we did the same on top and bottom. Right? I'm allowed to do whatever I want to do as long as I do the same on top and bottom. And then the 8 and the 14, can these both divide by something?
Yeah.
They're both even, right? So we know for sure they can divide by 2. And I think that's the biggest thing they can divide by. 8 divided by 2 becomes 4. 14 divided by 2 becomes 7. And what we're really multiplying now are the numbers that we have left over. And instead of the, like, I don't really want to do 3 times 14 or 8, like 8 times 9. I mean, we could do those. But I want to re-encourage, this is another way we can solve these. 12 over 7. Now let's imagine that I hadn't done the cross reducing. I'm going to put it up on the TV, so if you still need it. Let's imagine I had not done that, right? But I got 12 over 7. If I do the multiplication straight through the top, what's 8 times 9? Anyone know that?
72.
Yeah, 72. Over 3 times 14, 42. Well, I know they're both even, so I can divide by 2, right? 36 over 21. Can divide by 3, 12 over, oh, same answer.
But you have to keep reducing.
Well, we will need to reduce here, like coming soon. What we're really working on right now is just getting the new multiplied fractions. So if you can get to 72 over 42, that's good for like now. But then we will need to be working on the strategy of I divided by 2 on top and bottom, and then divided by 3.
Don't you always tell us to get never, like, go 8 times 9, 3 times 14? Don't you always tell us never to do that?
No, yesterday I was telling you to draw the arrows, and that's exactly what we did. Addition, we can't do that.
Oh!
Yeah. So this is where we have to brain switch, right? We have to flip that switch in our brain. Multiplication has a different set of rules. So with your team, work A through E. I'm going to give you 2.5 minutes. These should actually be quick. They're easier than adding fractions. Go straight through the top, straight through the bottom. And then reduce if you want to. My advice is draw the arrows. You don't have to take my advice, but that's my advice. little bit more like that for your health? Maybe you look at what kind of spell it out. You need some help on like A or B. It looks like you got some local experts there in your group, right? Guys, if you see someone in your group struggling, ask if you can help them. I was curious what it was. Like I said, it was like yellow or something. Who did? Nice. Natalie, you also got marked absent for some reason. So it's okay, we know you're here now, but it's all good, thank you. Well, apparently attendance didn't work quite right today. Alright, guys, put the calculator down. I wish that thing would electrocute your hands. Okay, here's the thing. I would rather you get a wrong answer, but be working to understand the process and asking questions and all that, than to just grab a calculator and do it on there. Now, I'm not picking on Nathan. I've been seeing other students like walk up and, hey, where's the fraction button on this thing? Where's it? Like, we have other skills to avoid using the calculator. So there is, but there is. It's ND, not ABC. Because straight across. And if you can't remember your multiplication skills, it's okay to count on your fingers. I still count on my fingers. It's okay. What's 7 times 5? 35. 48. Sorry, I heard somebody stop at 40.
Wait, I didn't say that right.
Any questions on A? B, 2 times 4.
8.
Hey guys, I need us with us because if you're talking and somebody has a question, they're not going to be confident enough to ask the question. Okay, so you're making a bunch of noise, it's going to be hard for them to be like, yeah, so chill. 13 times 5. 65. That's kind of a weird one. 6 times 6? 7 times 7? 4 times 3? 7 times 8? Sorry, Joey said wait. And I was, yeah. Sure, but we don't have to. Right, so I'm not going to force that score right now. I'm just going to keep reminding you guys occasionally this is how it works. Later, we'll like need to use it. Then do it. I'm not telling you don't do it, but I'm not going to make everybody do it. 6 times 1.
42. You said 42? I said 22. He said 6 times what I said.
No, he's just talking as fast as possible.
Yes.
Okay. Silencio, por favor. Does anybody have any, absolutely any, question or confusion on this set of problems? Are we sure? Because we're going to have a mastery, even if it's a mini mastery next week. I thought about having a mini mastery today on this, but we're going to have a mastery next week. These should be easy, right? It's just multiplication. If you know your basic multiplication, I'm probably going to try to avoid even numbers as big as like 13, 14. To check that you know the skill, I try to use easier numbers just to check your process. So does anybody have questions on this? Riley.
A, why isn't it 16?
Sorry, what?
Why isn't it 16?
For A?
Yeah.
Why isn't it 16? Over what?
No. Why isn't it 16 instead of 48?
Because 8 times 6 is 48. You go straight across the bottom.
8 plus 6 isn't even.
Yo, absolutely not. Whoever did that. We multiply, because there's multiplication between. We multiply straight through top, straight through bottom. We don't have to reduce yet at this point. We just want to get to the new answer. I don't even know if that would be reducible, because we can't divide by 2 or 3 or 4 or 5. All of those are out, so that'd be a hard one to reduce. I don't know if we can. I'm not sure. But at this point, we don't have to. Ava?
On the test, I'm really bad at like multiplication. So like, are we going to use a calculator?
Yes, but if you don't know how to change the settings on the calculator, which I'm not teaching you yet, you're going to get the answer like as a decimal or as like a reduced fraction, and I'm not going to want to see the reduced fraction first. So as long as like what you use the calculator for is typing in like 8 times 9, not 8/3 times 9, like do the top multiplication, then the denominator multiplication, like that's okay. Yeah, if you're still not like great at your multiplication facts, and we'll work that. And as I give you those like CPM tools and those different things, or like you can explore some Khan Academy stuff to help you out, like we'll beef that up. Hayden.
I have a question on a calculator.
Yeah.
So I tried calculating a really long number to see what would happen. It has like a number, decimal, and then like M something, and M2.
So it's using exponents and probably actually scientific notation. You will be learning all about that in science, and we'll get there. It's more of an 8th grade standard. Come see me if you want to talk about that specifically. I saw him today. And maybe we can talk about it next week.
And by the way, I said about 8 years.
Okay, but you know what I mean by like it could have sounded like you were scoffing at somebody's. Yeah. So this works great, right? Better than the rectangle method, because that rectangle method I'd have to like split things into 14 pieces or like gross 13 pieces especially. That'd be hard, like it's an odd number. So forget about the old rectangle method unless you really want to use it, and then that's fine. But I got a new rectangle method for you. So this is actually called the area model. So please, on your paper, put down 297 and then write area model. And this should be familiar to the problems you've been doing on your homework. And actually, a couple of you guys I wrote, please come see me about area model, because you're just not doing it quite right. And this is a really good tool to use when we have numbers that are a bit complex. So get down 97, write down area model. When we have numbers that are slightly complex, 172, 84, like kind of hard to work with, right? Because we don't know those facts. I don't know what 84 times 172 is. Like, who does? We break the numbers up. That works for whole numbers, breaking at the ones place, tens place, hundreds place, whatever, or mixed numbers, breaking at the partials. So please set up like a square, rectangle, whatever you want to do on your page. Notice we gave the 3 more space than we gave the half, because 3 is bigger than the half. Notice that we give the 1 more space than the half, because 1 is bigger than the half. So please set up this square on your paper. This will be familiar to what we've already done. Based off when we did this with whole numbers, go ahead and try to fill in the parts of that square. Because we are multiplying 3.5 feet by 1.5 feet to find the area of that section. Growing grass is a pain. Good thing Rona decided to make a flower bed. The city came in and fixed the pipe of mine, but when they replaced it with really terrible grass.
Wait, are we doing, so it's multiplication when you're doing it across, right? So it would be like 3 times 1.
Yeah, so this box is the multiplication of 3 and 1, 3. This is the half and the 1, so what's half of 1?
Well, 1/2.
This is the 3, and then that half.
That's 3/2?
Yeah, I'm just going to leave it as a fraction, 3 halves. Or we could do 1.5.
Yeah, but...
Now, this is the weirdest one. People will often goof this up. What's half of a half? 1/4. Good work. So check it. Let me put them all together. 3 half. 3 halves and 1/2. How many halves is this together?
4.
Now, advice. right? Not things you have to follow, but advice. Do these boxes first. These boxes are going to tend to be kind of like terms in a way. They group together easily. So 3 halves and 1 half makes 4 halves. What is that?
Oh, wait, what?
Sorry, people already said it. Is that 2, right? 4 halves is 2. So these make 2. So I really have 5 and a 4th.
Oh.
That's it.
Does it make sense one thing?
Yes.
I know 107 times 84 is 1,280.
So I'm not going to put that in the calculator right now. All I'm going to say is there are a couple people who tried to do the long stacked multiplication on like an assessment or homework or something. You did it wrong. Like I do not stack multiplication more
They add
ever.
zeros.
They actually their math was just slightly wrong. Seriously, guys, like the strategies I'm giving you, this comes from having like learned all the old ways, been in college to learn all the new ways, and then been out for like 7-8 years now to see it with 7th graders, like what works. Trust me, stacked multiplication is not really the best method. It just isn't the best method for your brain. I'm sorry. Like the breaking up multiplication, that works. Now, if you've gotten really good at it, you've developed that skill, and that's okay. You can keep doing it. Is that, yeah, what's up, friend? I mean, the bigger values that we start working with in decimals and fractions, I'm really going to encourage you to write some things out, even if you do parts of it in your head. Like, so I call those numbers working numbers. Shh. They weren't part of the original problem, and they're not my answer, but they're my in-between values. I would encourage, yeah. So that's okay, just as long as you like check your work and like make sure you're being careful. But like for you, especially, I know that you're careful and you like pay attention to those things. So that's fine. But I would caution other people. I mean, like even yesterday, Jose wanted to come up and share. Do you remember part 2 of the tightrope thing yesterday morning? Was like that huge long expression. Jose had a bunch of lines drawn and arrows and things. His answer was perfect. But if I looked at his paper, I would not have really understood how he got it, because he did a lot of it in his head. So some of it is what works best for you, but some of it is I need to see the evidence. Now, this worked, right? Rhoda figured out her area. However, there's another way, right? So I forget if they give us a name of who comes up and says do it a different way. So Rhoda did it this way, right? Okay, they don't give us another name. So let's say I walk up. I'm like, yo, Rhoda, I like your box method. Right, but that's a little bit, that you're trying really hard. I'm like, good effort, but I can do it easier. And Rhoda's like, all right, fine, show me. So 3 1/2. Can I make that into just one fraction, not a mixed number? Yeah, we make it what? Improper, right? So take 3 1/2, make it improper, and it becomes 7 halves. If we take 1 1/2, make it improper, it becomes 3 halves. What do we get when we multiply those? 21/4. What is that? 5 and 1/4. So whether you want to break the numbers and do an area model multiplication, or you want to make them improper, either way works. Cool? Try whatever method you want. You can do the area model, break it up, or you could do impropers to calculate this other flower bed. 1 1/2 by 5 1/3 is 98. Not heavy enough to keep that thing held down. When you lean forward. In your brain, the area model might be easier. In your brain, the improper fractions might be easier. Where's your work for this? Does this group need a handwritten invitation? No, I was going to go. So guys, write down the original. Always write down the original. Even with the mixed numbers, always write down the original. So like, and that again is advice from years of seeing who makes mistakes, and it's the kids who aren't writing down the original problem. 5 1/3. Be careful with that. Yeah, if we were trying to add these, that would be kind of annoying. So do you want to do the box method or the improper method? Okay, so we do the box. I'm going to do the box on black. And don't worry about the sizes of things, really. But it's 5 1/3, 1 1/2. Also, your group can help you because we can send these that account over there, but because I'm going to go and no one else has to help us. We work kind of like Battleship. So 5 times 1 right here would be 1/3 times 1. 5 times a half. That's the easiest way as a fraction. And 1/3 times a half. 1/6. Now this gets really annoying because now you have to add those. And you don't have common denominators. So I'm going to show you that this like that makes it harder here. Hey, so make them improper. So Ava, go the improper section way. If you set up the area model, you end up with a fraction that is 1/3, a fraction that is 5 halves, and a fraction that is 1/6.
Yeah, that's a problem.
Wonderful, we can add those. Who actually wants to add 3 fractions with different denominators?
No.
Not me.
I do.
Sure, if you want to, go for it. However, I got an easier way, right? And I told you my job is make your life easy. So the easier way, make them improper. What's 1 1/2 turn into when it's improper? 3 halves. What's 5 1/3 turn into? 16 thirds. 3 times 16. I gotta break this up. I get 30 and 18. Because 3 times 10, 3 times 6. So that's 48 over 6. Be careful.
Oh, I'm sorry.
You added not
And then, or it could be 9 to 2.
Or when we reduce, it can't be 9.
Oh, sorry. No. 8.
8 and still 3/5.
No,
3 6.
No.
3.
8.
So let's say check the reduction. So check how many 6s going to 48, right? 6, 12. Guys, here's how I count on my fingers, and I'm not
I did it
joking.
wrong.
Like 100% honest truth. If I was trying to check 48 divided by 6, like as a 29-year-old with a bachelor's degree in mathematics, 6, 12, 24, 48. And I doubled to get my way there. I still count on my fingers. Not joking. Okay, as long as you can do it quickly. As long as it works for you. This is just 8. And I didn't have to add any fractions. Ava, does this make sense? You're making a face. Your body language is amazing because I can read whether you understand it or not. Yes, I said Ava. No, Ava. You get this. How we made it improper.
Okay, so what I'm getting is that I don't understand. Like, this does not make sense in my brain. Why don't we need common denominators? Like, that just does not make sense to me.
So, what we're like, it's a hard question to answer.
I can answer it.
Okay, Aiden, give it a shot.
So basically, you don't need common denominators because you're just multiplying fractions. All you have to do is say, so the 1, no. So 2 goes, there's 1, 2, so it equals 3 over 2. I can't see. Now, and then, so you would know, you also would know, I just lost the problem. Okay, whatever. Ava, you don't need common denominators because you're just multiplying straight across the bottom and the top.
Yeah, but why was it adding? Why can't we just add
But we're not adding.
So check it. Let me see if I can help.
We're not adding.
If we try to apply the same technique with addition, straight through top, straight through bottom, I'm gonna get 6 8s. Do not write this down. This is not true. 2/3 of something, if I had a something, I have 2 of the thirds, right? Really bad drawing. And then 4/5 if I have another one thing, and I have it split into fifths. Guys, if you're good on the last problem, move on to the next work. Down below in 99 and 100, there's just a little bit more practice with this. And honestly, I think if you're really comfortable with this, you can probably just start working on your practice for tonight.
Yeah,
So Ava, I got my 2/3 here,
Yeah.
and my 4/5. If I put these together, I'm going to have more than one, right? Like, obviously, this isn't more than one. This doesn't work because the portions aren't the same size. So to make them the same size, I would have to split this to get 15 boxes, and split this to get 15 boxes.
You know, that was a stupid question because I know what I'm doing.
So, but here's why we don't need common denominators in multiplication, because that's just why we do need them in addition, right? Multiplication of the same thing, 2/3 times 4/5. I surveyed the 7th grade class. I'm going to make this up. And let's say 2/3 of them are under 13. So 2/3, right? 2/3. 4/5 of those 2/3 want ice cream at lunch. I don't know, I'm just making stuff up. So then we go this way, like we were doing yesterday. We have to split this section up into fifths, but I can't go the same way that I already split it. Right? Same 7th grade class. I just split it into fifths that way, and I shade 4 of them. So then the answer is all the regions that have been double shaded by both fraction area 1, 2, 3, 4, 5, 6, 7, 8 over. We've now made 15 total regions. So what I can now say, 8/15 of the 7th grade class are under 13 and want to eat ice cream at lunch. Like, you know, does that make sense? Good. All right. Please start on, well, I'm going to check on 99 and 100, but I think we're good to just start on homework, and then I can pass stuff back. So my best advice, use the improper fraction method. It will help you avoid adding fractions. So kind of like a challenge problem that we were going to look at, but I'd like to just give you guys some time to work on your homework. Be careful, like in 101, or sorry, in 100, if you are looking at different units, that's going to mess you up, right? You cannot add different units. So here, give me your attention for just a second. If I have in 100 these different units of like feet and inches, I need to choose a unit to go to. 8 inches is out of, how many inches make a foot? 12. Right, so an entire foot, if we measure it in inches, is 12 inches. So 8 inches, if I try to make it a fraction with a label of feet, would be 8/12 of a foot. Right, so you have to think, how do I convert those units? We're going to do more of this as we go through, but like 6 hours. How many hours are in a day? 24. So this is really 6/24 of a day. Kilometers. Who knows what kilo means? What's the prefix kilo mean? Kilometer, kilogram, like it's 1,000. Yeah, like so. This we could just replace it with 1,000, or this we could say it's over 1,000 kilometers if we want to change that to a fraction. Or this, if we want to change it to meters, would just be 14,000 meters. We could change either of them. I got papers to pass back. Aside from that, work on your practice for the next 8 minutes.